Good afternoon. Welcome to this session on delta sharing in action, architecture, and best practices. I am Darshana, a product manager on the delta sharing and collaboration team here at Databricks. And my co-presenter is Mingxi Chen, senior engineering manager on the team. Before we get started, we must show you this very important slide, our forward-looking statement. Here is our agenda for the session. This is going to be a deep dive session on delta sharing, and we'll be sprinkling in some awesome demos for all of you to see. We'll talk about what delta sharing is, how customers are using delta sharing today. We'll discuss themes of investment and what's new with delta sharing. We'll talk about a very exciting new partnership with SAP, the integration which is powered by delta sharing. And then we'll top the session off with best practices so you can gain the most out of delta sharing. Secure, flexible, and open sharing propels innovation in organizations. It helps elevate customer experience, improve business outcomes, provide a competitive advantage. However, data sharing is complex and expensive today. Why? Firstly, most sharing protocols are proprietary and they result in vendor lock-in. Other methods like SFTP are manual and quite error-prone. These methods don't allow seamless sharing of data across platforms and clouds. Second, most sharing methods result in data duplication. This means you're dealing with multiple copies of the same data, copies sometimes going stale, and the operational overhead and the cost associated with all of that. And finally, most sharing methods are not built for today's age of AI. That's why we built delta sharing. First, it's an open sharing protocol. You don't need to be on Databricks to use it. Even if you are on Databricks, you can share with recipients outside Databricks. So truly, you can collaborate across platforms and clouds seamlessly. Second, with delta sharing, it isn't a protocol which copies data. It's a no-copy sharing protocol. So you're not dealing with multiple copies of the same data, copies going stale, and the cost associated with all of that. And finally, very importantly, when you use Databricks managed delta sharing, you can share more than just structured tables. With it, you can share unstructured arbitrary files. We call these volumes. These can be PDFs, images, video files. You can also share AI models and notebooks. When you use delta sharing on Databricks, you get Unity Catalog under the hood for governance as well. So let's double click on what open sharing and no copy sharing means a little bit more. As a data provider, you don't need to be on Databricks to use delta sharing. You can spin up your own delta sharing server and start collaborating. Even if you are on Databricks, you can share to recipients outside Databricks. We have connectors to many popular tools like Power BI, Tableau, Spark, Java, and so on. And in fact, about 40% of shares that go from Databricks today go to recipients outside Databricks. So what does no copy sharing mean? As a provider, when you make an asset available to a recipient, basic metadata is exchanged between provider and recipient, but there isn't any copy of that data that's made. It's only when the recipient runs analytics on their side that data movement happens from provider to recipient. The recipient always has access to live, fresh data from the provider. So that's why we say it's a no-copy sharing protocol. Customers are using delta sharing today for a wide variety of use cases. Of course, lots of customers are doing internal sharing across business units. Customers are also breaking down organizational silos and sharing data using delta sharing with their vendors and partners. Third-party data providers like IQVIA, FactSet, they are distributing licensed data using delta sharing. And SaaS partners like SAP, Oracle, Twilio, Atlassian, they are allowing customers to bring SaaS data from their platforms into Databricks, and even vice versa in some cases, using delta sharing. So let's talk about how one specific customer is using delta sharing today. HP is revolutionizing their 3D printer business using delta sharing. Previously, they had all this fragmented 3D printer telemetry data that they weren't able to share seamlessly with their customers. Enter Databricks Managed Delta Sharing. They're able to share this 3D printer telemetry data seamlessly in near real time, and their customers are able to do predictive maintenance on top of this data. Overall, this has enhanced efficiency, reduced downtime, and truly boosted customer experience. HP actually did a deep dive session on this use case on delta sharing yesterday at Summit, so in case you missed that session, feel free to take a look at the recording, which will be available online soon. So since making delta sharing generally available about 3 years back, we've seen skyrocketed adoption. There's an over 300% year-over-year growth in delta shares. And as I mentioned previously, the value prop of the fact that you can share with recipients outside Databricks has really excited customers. Over 40% of shares that originate on Databricks go to recipients outside Databricks. We've been working very hard on making delta sharing better for all of you. And our primary themes of investment have been as follows. First, we've been working on making the ability to share all types of data assets, diverse array of asset types. Second, we've been working on being able to collaborate with anybody, irrespective of whether the recipient is on Databricks or outside Databricks. And finally, very importantly, we've been working on making delta sharing a friction-free sharing experience. We have a lot of awesome capabilities that we've introduced recently across these different themes. So let's dive into each of these. First, let's talk about sharing a diverse variety of asset types. I already mentioned that with delta sharing, you can share tables, files, notebooks, AI models. Now, we're happy to share that you can share even more diverse asset types using delta sharing. The first is through sharing for Lakehouse federation. So let's assume in your organization, you have finance data in Snowflake, you have marketing data in BigQuery, you have transactional telemetry data within Databricks. Using Lakehouse federation, you can leverage a single SQL engine within Databricks to process all of this data without ingesting the external sources into Databricks first. With sharing for Lakehouse federation, you can delta share these foreign assets without first ingesting them into Databricks. This capability is available in private preview, with public preview coming very soon, and we support a wide variety of foreign sources, or federated sources, including Synapse, Azure SQL, Redshift, Snowflake, BigQuery, and so on. I'm sure all of you here are familiar with materialized views and streaming tables. MVs are pre-computed views that are built on top of a base table, and they're refreshed on a regular cadence. And streaming tables are basically live delta tables that have streaming data coming into them. We're super excited to share with all of you the public preview of MV-ST sharing, with GA coming very soon. Previously, in our private preview, you could only delta share MVs and STs to Databricks serverless recipients. Now you can share MVs and STs to all recipients, including open recipients. And with our upcoming GA, we're adding even more capabilities, like the ability to share views built on top of MVs and STs, and the ability to build views on top of shared MVs and STs. Next, let's talk about data filtering capabilities. I'm sure all of you here will agree that fine-grained access control is super important in enterprises, right? You want to make sure that Bob, within your company, has access to all the right data so he can get the job done, but he doesn't have access to anything more than he's supposed to have access to. There are two ways to think about fine-grained access control when it comes to delta sharing. The first is through dynamic views. With this capability, you can slice and dice data into views and make views available to your recipients. Within your view definition, you can leverage the current recipient function to conditionally apply filters based on who your recipient is. So in the example here, if my current recipient's tier is paid, then they can view customer contact information. Otherwise, we redact that information. So this capability is available right now, generally available. And there are a couple of things to keep in mind with respect to dynamic view sharing. So if we trust the recipient compute, if the recipient is within the same Databricks account as the provider, right, or the recipient is using Databricks servers, even if they're on a different Databricks account, we provide direct access to the underlying data. If the recipient is an open recipient, for example, we pre-filter the results of the view on the provider side before making it available to the recipient. And we do this because delta sharing is a file-based sharing protocol. We want to make sure that the recipient gains access to only what they're supposed to gain access to. So if pre-filtering happens on the provider side, there is some compute which is utilized. There's also storage which is utilized to store the temporary materialized results. And of course, you need to make sure that the storage of the temp materialized results are accessible to the recipient. So network connectivity considerations as well to keep in mind. View sharing has been one of our most popular recent launches. We already have thousands of customers using this in production today. So highly encourage you to take a look and leverage it and share feedback with us. So the next way of thinking about dynamic fine-grained access control with respect to sharing is using a new paradigm for governance within Unity Catalog called ABAC, or attribute-based access control. So how many of you here have attended sessions at Summit this time with where ABAC was discussed in detail? Maybe there was a UC session. Okay, so seems like some of you, but not actually a lot. So very quickly, what is ABAC? ABAC allows you to set dynamic context-sensitive policies on tops of groups of assets within Unity Catalog. And you can think of ABAC as the next gen of the more traditional RLS CM paradigm for fine-grained access control within Unity Catalog. So ABAC consists of attributes, right? These provide context about assets, users, or environments. An example attribute could be a column tag. Here in this example, you can see the SSN column is tagged with PII. ABAC also consists of policies. These are rules that dictate users' access by looking at attributes. So an example policy could be if column is tagged as PII, then mask the column. And what's awesome about ABAC is inheritance is followed across the UC hierarchy chain, unlike traditional RLSCM, right? So policies are attached to catalogs or schemas, and they apply downwards. So we're super excited to share that ABAC within Unity Catalog is now in private preview, but we also have delta sharing of assets, tables, MVs, STs, which have ABAC policies enabled on them. This is possible right now in private preview. So if you are a privileged user on the provider side, you're excluded from an ABAC policy associated with the table, you can delta share the table. Previously, we did not allow sharing of tables or assets with RLSCM. Also, on the recipient side, you can now construct ABAC policies on top of shared assets. We're also going to support traditional RLSCM application on shared assets on the recipient side. So if you're interested in participating in this preview, we'll share a QR code at the end of this presentation where you can sign up. And with that, let me pass the baton over to Mengxi to show you an awesome demo of some of these capabilities.
Okay, cool. Cool, that was a lot of great features. Now let's see a live recorded demo of them working in action together. All right, let me first talk about it. So this will be a demo of sharing materialized view, streaming table, and federated table together over to a recipient, and then govern that with attribute-based access control policy. All right, cool. Now we finally have it playing. So now let's imagine I'm a data provider. I'm preparing a data set to help another BU of my organization to do data analysis on some customer cohort analysis. So for this, I will need streaming table, which is prepared by my colleague Sun. He's a big Databricks DLT user, and he uses that for all of the ETLs. And now I have this e-commerce sales streaming table available, and for this data analysis, I also need to pull in this tech sector performance, which is the materialized view. Also, as we are doing the customer cohort analysis, I also need to pull in some external data that reside in Snowflake, which are about the sales application. So in this case, my colleague Paul have already set up a Lakehouse federation connection to Snowflake. And now let me grab 2 tables from here, online user activity and customer retention. Now let's switch to the Delta sharing UI, where I will be packaging all of these different diverse data sets together, streaming table, materialized view, and foreign tables together. And now let me share with my recipient. Cool. Now flipping persona to the recipient side. Let's imagine I'm a data administrator on this recipient side. And what I'm trying to do is to install this chair to be ready for my data scientist. And there's one more thing I need to take care of, because some of this customer data actually contains PII information. And I want to govern that with the attribute-based access policy, so only authorized user have the access to the PII. All right, now let's see how that's done. As you can see, I already have this share installed in the catalog. Now let's go to the catalog. On the catalog, there's already a policy created. Let's click into it and see what's inside. As you can see, this is a policy aimed to mask PII information to only authorized user. And this policy applies to all of the account user. And the policy target type is a column mask. And it's targeting all of the tables and schemas within this catalog. And for this column mask function, it's pretty simple. If the user is in this PII access group, they can see the PIIs. Otherwise, it will be masked. Now, let's go back to the customer information tables. As you can see, I've already tagged some of the PII columns with the PII tags in here. And together with the catalog level policy enforced on this table, I should be able to see, my data scientist should be able to see masked information. Now, let's go to the sample data tab and see. Okay, as you can see, all of the PII columns has been properly masked, and now this data set is ready for the data scientist analysis. All right, cool. Back to you, Darshana.
Awesome. Thank you, Mingxi. We've been doubling down on our open sharing value proposition by making open sharing even more secure and working on Iceberg interoperability. But before I dive into the specific features that we've launched, let me provide a quick refresher on how open sharing works today. So if you're a data provider on Databricks sharing with an open recipient outside Databricks, there is a profile file that you distribute with this recipient. The profile file contains your sharing server endpoint as well as a bearer token. Your recipient uses the information in the profile file in tools like Power BI, Tableau, and consumes contents from the share. I want to point out a couple of things with regards to this workflow. First is, there is a bearer token which is exchanged between the provider and the recipient. Second, the bearer token tends to be long-lived. Third, the life cycle of the bearer token needs to be managed by the provider. And finally, the provider can't specify individual users or groups within the recipient organization who can consume contents from the share. They can specify IP ACLs that the recipient organization should adhere to, but not individual users or groups. We're super excited to bring to all of you the general availability of secure open sharing with OIDC token federation. This truly elevates security of open sharing. With this feature, providers can bring their own IDPs or their recipient IDPs like Entra ID, in order to mint tokens on behalf of recipients. So we spoke about the workflow previously. Here, there is no secrets sharing that takes place between provider or recipient or Databricks, so very secure, secretless sharing. Second, the tokens are short-lived. Third, provider doesn't need to worry about lifecycle management of these tokens anymore, because the IDP does it on their behalf. And finally, and very importantly, the provider can specify individual users or groups within the recipient organization who can access the underlying share. So much more fine-grained access control. We support 2 scenarios for this capability. The first is U2M authentication. This is where you have human users interacting with the underlying share, with support for Tableau and Power BI clients. And we also support M2M authentication, where you have a machine interacting with the underlying share. So we have OAuth client credentials grant flow with Python and Spark connectors already available. And we have support for managed identity with Azure VM coming very soon. And so back to Mengshi to show you a demo of how this works.
All right, cool. So this will be a demo of U2M authentication flow using Microsoft Entra ID to access shared data in Power BI. All right, let's imagine I'm a data recipient. I'm trying to access some of the sales performance data shared with by my provider. And I want to restrict this access to only authorized user in my Entra ID tenants. So here's how do I do that. So first, there's two key pieces of information I need to grab from the Azure portal. First is the Azure Entra ID tenant ID. Let's take a note of that. And now let's go to the groups. And let's find the group I want to grant access for and note their group ID. Now I will share these two information with my data provider, who will set up their Delta share as normal. And they will come to this here to create an open OIDC federation recipient. And after that's created, let's grant the share to the recipient. And in order to control access, the provider will come here to configure an OIDC policy. And in this case, the issuer URL will be the Entra ID's login URL with the tenant ID in place. And for the subject claim, we're going to use group with the Entra ID group ID input here. All right, and lastly, for the audience, since this is going to be accessed from Power BI, we're going to input the Power BI Entra ID app ID into the audience. And once I click Save, OIDC profile URL is generated for the data provider to share with the recipient. Now, the recipient user opens up Power BI to access the shared data. They first go to the Delta sharing profile URL and grab the Delta sharing server endpoints, which they will input into Power BI. And now they will start the sign-in process, which is, in this case, federated through the recipient's Entra ID. And the user will sign in as usual, and they will be prompted for multi-factor authentication as their IDP configured. And after signing in, the recipient now have access to the shared data inside Power BI, which they can use, which they can start consuming with drag and drop to render a bar chart of the sales performance data. And to quickly recap, in this demo, we showed using the recipient's identity provider. But with the OIDC policy, actually allow you to configure whatever trusted IDP to use. It could be also the data providers, and so you can configure that accordingly. It's very flexible. All right, now back to you, Darshana.
Thanks, Mingxi. Last year, there was a lot of chatter on data formats. What's the best data format? Is it Iceberg? Is it Delta Lake? Last year, we acquired Tabular, and the founders of Iceberg joined Databricks. The founders of Delta Lake are also here at Databricks. We strongly believe that fragmented data formats are not helpful to all of you, our customers, and not helpful for our industry. And our stance is Databricks works out of box, irrespective of the underlying data format. And Delta sharing follows suit. We're super excited to share with all of you full Iceberg interoperability for Delta sharing, both on the provider side as well as recipient side. As of today, you can Delta share managed Iceberg tables as uniform to both Databricks as well as outside Databricks to open recipients. You can also, as a recipient, consume shares within Iceberg IRC compatible clients, including Snowflake. So why not take a look at a demo of how this works instead of talking more about it?
Awesome. So I know this will be a big demo. Many are anticipating, so let's do it live. All right, cool. So let's imagine I'm a data provider. I have this piece of daily weather forecast data hosted in Databricks in the Delta format. And now I want to share it, I want to deliver it to one of my customers who's using Snowflake. How do I do that? So the first step will be enable uniform. So with uniform, it automatically generates Iceberg metadata behind the scene without needing to rewrite any of the data files. And uniform provides interoperability between Delta and Iceberg formats and enable any Iceberg reader client to access. So I have this command prepared here. which I'm going to enable column mapping, Iceberg compatibility, and uniform on my table. Now let's run it. All right, with that run successfully, my table is all set, and let me add it to the share. Cool, I have added to the share. Now let's go to the share if it allows me to click. All right, as you can see, I have the same piece of daily weather forecast data in both imperial and metric format. And I've already sharing with an open recipient. Now let's flip to the recipient side. So as the recipient, I will get an activation URL from the provider, in which case I visit this page and I've already downloaded my share credential file. And now I click the Snowflake logo and I will upload the share credential file I just downloaded. And now I'm going to select the share I got and select the imperial format which I want. And next, I will click Generate SQL, which will automatically generate the SQL command I can use in Snowflake to install this share. Now, let's go to Snowflake and paste this command in. So let's first walk through what this is doing. So the first command is to create an Iceberg catalog integration inside Snowflake. As you can see, the source is the Iceberg REST catalog, table format being Iceberg. And as you can see, the REST catalog URI is actually a Delta endpoint hosted in Databricks. And another thing to call out is the access mode. In this case, it's vended credential, which means Snowflake will use the credential vended by the Delta endpoint to directly access the table files in the cloud storage. And for authentication, I'm just using the bearer token included in my share credential file. And now let's name our catalog as uniform Delta sharing. All right, the second command is to create the Iceberg table inside the catalog I just set up. So let me name the table as well. All right, cool. Now let's run this command. So as you can see, we have the catalog created, and now let's create the table. This command could take a few seconds to run, as Snowflake is preloading the table as it creates. All right, I have the table created, and now let's run our select start. Cool. I have the query result here, and keep in mind, this is a live query going direct against the Delta table that's hosted inside Databricks. And also, as a recap, this is a demo of sharing to Snowflake, but with uniform and the Iceberg REST catalog API implemented by Delta. It actually enables you to share your Delta table with any Iceberg reader clients, including AWS Glue, Trino, or Dremio. Cool. And now let's go back to the presentation.
Awesome, thanks, Mengshi. To make Delta sharing a friction-free sharing experience, we are very excited to bring to all of you Delta Sharing Network Gateway. But before talking about the specific capability, let me provide some color on what the current pain points are. So as a data provider, you have data behind a storage bucket, which is behind a private network. You want to make it accessible to your recipient without exposing it to the public internet, right? Similarly, on the recipient side, you have your infrastructure that's behind a private network. You want to collaborate with the provider without compromising your infrastructure. So what's the workflow that happens today? Provider needs to allow list recipient IPs to make sure recipient is able to access storage buckets. Recipient similarly needs to update their Egress firewall to make sure that they can access provider storage buckets. And this, as you can imagine, can become quite complex if a provider is sharing with hundreds, thousands of recipients and vice versa. And network security admins are getting involved now in this entire workflow. So we're very excited to present to you Delta Sharing Network Gateway, which will be in private preview very soon. We're already accepting interest, so if you're interested in signing up for this, let us know. We'll share a QR code at the end of this presentation. And very simply, how this works is at max one time, provider makes a connection with Databricks' storage gateway service. So one time you enable your storage to access our storage gateway service, and after that, we do all the heavy lifting of being able to, of enabling you to collaborate with n number of recipients. Similarly, if a recipient is on Databricks, irrespective of whether the recipient is on Classic or serverless, we automatically connect to storage gateway service, so seamless collaboration can happen with multiple providers. Next, I want to share with you a very exciting partnership highlight with SAP. Using Delta Sharing, we enable bidirectional sharing of data from SAP Business Data Cloud into Databricks and vice versa. SAP needs no introduction. SAP has over 400,000 customers today. Very likely your organizations also use SAP today. More than 90% of Fortune 500 organizations use SAP for so many different use cases: revenue, cash flow, profit forecasting, production optimization. Yet, our customers, and perhaps you've experienced this as well, have told us that bringing SAP data into Databricks or data platforms like Databricks is complex today. It's expensive, requires replication, not very performant. And customers are bringing all this data to leverage our data intelligence platform's capabilities for analytics, machine learning, AI. So we're very excited to bring to all of you a delta sharing integration that will make this process very simple. We have a launch coming up in Q3. You can bring both custom as well as curated data products from SAP BDC into Databricks. You can share back to BDC as well. BDC is an end-to-end cloud analytics platform on SAP itself. So what BDC does, it takes away the heavy lift work of creating data products from scratch. So they take away the ETL requirement, and it comes out of box with a ton of curated data products. So again, if you're interested in learning more, we actually did a deep dive session on this integration just before this session, so we highly encourage you to watch the recording. And we're also happy to connect after this session to share more about this capability. And with that, I will pass it back to Mengshi to share more about delta sharing best practices.
Cool, thanks Darshana. That's a lot of great feature and capability got unpacked. So as someone from the engineering team, that's particularly exciting for me to see them deliver to you guys on the customer to empower your data sharing use case. And now let's change gear a little bit. We also want to share with you some of the best practices over delta sharing to hopefully improve your data sharing use cases. So I'm sure many in the audience have already used delta sharing, or you at least used it once. And you probably would agree with me that getting your first share set up is pretty easy. It's just a few clicks of work. But as you continue to grow and expand your data sharing use cases, there are things you need to pay attention to get right as they scale. So in today's session, we're going to talk about what you can do to optimize the query performance. We're going to look at a large-scale data sharing use case inside Databricks of this Databricks system table. And we're going to, if time allows, we're going to talk about ways to consume shared data, reducing egress costs. And then the best practice won't stop here. My colleague Krishna and Bilal have given 2 great talks yesterday about how to manage network security, how to choose the right data sharing product for your use case, and you can catch up with the recording once it comes online. And now let's first start with performance. So I want to give a little bit context of how data access is given when you are delta sharing. So in traditional delta sharing, we use pre-signed URL, which is leveraging the cloud native pre-signed URL to provide temporary and secure access to the data files. So in the delta sharing flow, upon the recipients make a query to the shared data, the delta sharing server will load the delta metadata files and then to perform an initial data skipping decision to determine what are the files that need to be accessed by this query. And for all of the files that need to be accessed, it then generates a pre-signed URLs. And then all of the URL payload, it need to be returned to the client. As you can see, this could be a bottleneck for a very large table, as very large table could end up with millions of files that need to be pre-signed and then need to be transferred over. So as a solution, in modern delta sharing, we introduced another mechanism called Cloud Token Direct Access. The key difference here is delta sharing will use a scoped down Cloud IAM token to provide the client with access to the root directory of the delta table. And that brings the benefits of data processing mostly on the client side, which will be more efficient. And then it also completely eliminates the need to pre-sign each files and then transfer them over. So with Cloud Token Direct Access, from our benchmark result, it could actually yield comparable query performance as you are querying a local table. You must ask, how do I leverage Cloud Token Direct Access? The answer is history sharing. So in Databricks to Databricks sharing, when you shared your table with history, we automatically leverage Cloud Token to provide the recipient with direct access. Besides the performance benefit we talked about, it also enables client-side data skipping, which is more efficient inside the Databricks runtime. And also, it enables operation like CDF and streaming as well. At the same time, it supports all of the latest and greatest Delta feature. Two caveats to keep in mind. History sharing is not available when you are sharing only a subset of the table. For example, a specific partition. As in those cases, we cannot give it the root directory access. And also, direct access is not yet available in Databricks to open sharing. Now let's look at some numbers. So according to our benchmark results using the TPCDS 3 terabytes datasets, as you can see, the first column is local and the middle column is shared with Cloud Token. And it's very comparable performance with only 5% difference. And while it's 7x faster comparing to sharing on pre-signed URL. And the gap could be smaller if your table is smaller. And also, history sharing has been enabled default for all of the newly shared D2D table since late 2024. And since then, we have seen 5x more shared table now optimized with history sharing. And the way you can tell is to look at the data source field on your shared table. If it's Delta, it means you are already onboarded. But for those who are still on Delta sharing, you can still easily retro-enable using alter share add table with history command. And for performance, we won't just stop here. In Databricks, we have been working on more performance optimization to bring to you out of the box. For example, batch URL signing to improve the signing performance. And in the upcoming DBR release, Delta sharing will be able to leverage Spark IO cache to accelerate your subsequent query made it to a shared table. And in Databricks, we are continually working on more performance optimization in the Databricks server side. And also, we have planned to open source the Delta sharing directory-based access, so you can leverage them in D2O as well. All right, cool. Now let's look at data sharing at scale. And as I mentioned, we'll do a case study of Databricks system table. In case you haven't used system table or not familiar with it, these are the tables that lives inside the system catalog inside UC, which is aimed to provide customer observability over the entire Databricks platform. And under the hood, it actually used Delta sharing to deliver 20+ system schema to all of the Databricks users. So if you're using system table, you're kind of already using Delta sharing. Now let's take a look of how it works. In this diagram, this is the data flow of Databricks system table. On the left-hand side, it starts with a Databricks internal data capture over any billable, auditable, or feature usage event. And those events is later streamed into an internal workspace that present in every Databricks regions for initial data ETL. And once the ETL is done, the data is then Delta shared over to the destination region. On the destination region, the data will go through additional data enrichment and compliances treatment, after which it will be materialized locally onto the destination region's metastore. Now it comes to the final step, is to deliver this prepared data to the customer. And again, the fulfillment is done through Delta sharing, D2D sharing over the same region. Now, let's talk about some of the scales system table data sharing is at. As I mentioned, it's doing a cross-cloud data sharing across 60+, all of the regions that Databricks operates at among all of the 3 clouds. And some of the tables, system table could be extremely large. If you think about your audit log, your billing log, those tables are in multiple terabytes with millions of files. And also, system table need low latency ETL to meet their tight data freshness SLA. And since system table went GA, it has become very popular, which means there is a super high query volume to Delta share. And with 30+ million plus query made monthly. And also, the data sharing is very large scale. It's sharing from 100+ provider metastore to all of the Databricks customers' metastore. So now let's take a look at what are some of the best practices we used to scale system tables data sharing. It starts with predictive optimization. Predictive optimization enable automated data maintenance on your source table using optimize or vacuum command to improve the Delta files layout and also regularly clean up some of the unused data. This is in general beneficial for Delta sharing and for the data recipient, as it means there's less file need to work with. And also, its query changes. So system table leverage continuous streaming via DLT or jobs to perform incremental refresh, which speed up the ETL and improve the data freshness. And as I mentioned earlier, there's a super high query volumes, which could mean there will be unbounded cross-region or cross-cloud egress cost. And to mitigate that, the data is being materialized locally to each region, so when it's serving all of the queries in region without needing to worry about egress cost. And lastly is to automate the management. System table has been using Terraform to programmatically manage the Delta sharing provider recipient shares object. And also it later have evolved into its own services. I think we're a little bit over time, so I'm gonna skip a few slides here, but feel free to let us know if you have, you wanna discuss further, we're happy to meet. And then lastly, I wanna talk about managing costs in data sharing. So as Delta sharing itself is free, there still could be other cloud provider costs involved in data when you are sharing data. For example, data storage, network transfer, or most predominantly the data egress cost. Imagine if you are sharing data internally across many GLE distributed BUs, or if you are a data vendor who need to serve a customer base across the globe. In such cases, data egress cost could be inevitable when you are sharing out of region, out of cloud. So I want to highlight a few key features to help you mitigate egress cost. First is Cloudflare R2, which is data storage options that you can leverage, and it guarantees zero egress cost. Cloudflare R2 is already supported within Databricks Unity Catalog, which you can use to host the data you are sharing, and then stop worrying about egress cost. And Databricks, we have already also developed a solution accelerator to help you monitor your egress cost. It allows you to connect your Delta sharing usage log to your cloud storage access log for egress cost attribution analysis, so you understand the egress cost from each share or over to each recipient. And nonetheless, in some cases, it might be still worthwhile to consider replicating the data locally, which you can replicate the data locally to the region you are serving to. And to do that, you will first Delta share the data over, and then you will set up a Delta deep clone to create the initial clone. And afterwards, you can leverage change data feed to perform incremental refresh to keep the clone in sync. All right, I know we're kind of over time here, so I'll just wrap up today's session here. And as mentioned, we have a bunch of QR code here for the Delta sharing ebook, and we have the private preview of sign-up code for sharing to Iceberg client, and also for the Delta sharing network gateway, as well as the SAP BDC Delta sharing integration. So feel free to take a picture, and yeah, we also look forward for your feedback, and which you can submit over in the apps.